So now I'm very pleased to welcome Fred. Fred is from Yelp. In fact, he's one of the early employees at Yelp, and he's going to be talking with us about the ways they scaled the technology in the organization at Yelp. Really excited to welcome Fred and his laptop, so please.
Hi, thank you. Quick question before we get started. Who else wrote their name upside down on their name badge? Yeah, great. So if you're looking for me in the hallway track, you can just find Durf. That's me. My name's Fred. My clicker is not on. Now it's on. A little bit about me, help you feel more comfortable with this guy standing on stage in front of you. I currently lead our operations team at Yelp. I've been there for about 4.5 years. We're out in San Francisco. I've been there since the company was about 80 engineers large. We're currently several hundred and growing rapidly. But I'm no stranger to Ohio. I went to school up at Case Western in Cleveland, and I grew up in Pittsburgh. So I've got to do a shout out to my Pittsburgh sports teams. Hopefully that makes at least one person here unhappy. I'm really big into web operations, but I'm just a guy, and I don't have all the answers. I don't even have, some of the answers. But I do have some insight that I'm keen to share with you on what our experience has been like growing Yelp out in San Francisco. I need to talk a little bit about what Yelp is if you're not familiar. We connect people with great local businesses. Some stats, 89 million unique visitors on mobile alone every month. We got 90 million reviews and growing. We're in 32 countries worldwide. And you get to stats like that by growing, and that's what this talk is about. It's about growth. But particularly it's about growth in people. That's why there's people on this slide. I think most companies today are growing in some capacity. There's a lot of reasons you might grow. You might be looking for people to help you flesh out your cool new startup idea. I should warn you, I'm from the internet, so this talk is not going to make any sense, and it's just an excuse to show silly pictures. You might be going through a merger or acquisition. You might be expanding into new markets, conquering new territory, building new products, finding new business verticals. There's a lot of reasons you could grow, but growth fundamentally means embracing change. As you add people, those people are hopefully going to make changes. You're not hiring people to do nothing. Those changes are going to be making your existing products better, maybe adding new features, maybe even busting out new products. And as you go through this change, this really means that growth means embracing DevOps. Why does growth mean embracing DevOps? Well, DevOps is cool technology. We've talked about a lot of cool, technology that's frequently associated with the DevOps movement, but fundamentally, DevOps is about a cultural appreciation of change. DevOps tells us to embrace change, not to be afraid of it. Like for a long time, we've been afraid of change. Change introduces risk, and risk breaks things. That's not good. My ass is on the line for that. But DevOps is crucial if you're going to grow your company. As infrastructure builders and infrastructure maintainers, it's our job to be an agent of flexibility for the company. We don't tell the business what to do. The business will do the things that the business has to do, and it's our job to make sure that we can stay competitive. This is doubly important in the technology landscape and the business climate that we live in today, right? There's competitors at every turn. Business moves exceedingly quickly. And it's our job to be able to allow the business to leverage these advantages. DevOps provides cool tools to let us, build and define infrastructure. And this infrastructure is important, right? This is how our products are able to exist. This is how we serve customers. This is how we build technology. This infrastructure is also what allows those products to be flexible. That's what allows those products to do new things. But importantly, this infrastructure also scales people. This infrastructure is what allows you to add people. And as your company grows, you're probably going to want to change that infrastructure too. This makes changing your products seem easy, right? Changing infrastructure is hard. You've got to change the tires on the car while it's going 100 miles an hour. This is often harder than actually changing your applications and changing your code. And it's here that DevOps goes from convenient to critical. None of this will work. The dog is not going to get out of the room unless it has the cat helping him. We need to embrace the fundamental culture shift that comes along with DevOps and infrastructure as code. We can't do this alone. And this is why I think about DevOps as someone having your back. We talk a lot about collaboration with DevOps, but there's more to it than that. Not only are people your collaborators, they should be your allies. When you screw something up, you want somebody there that has your back. And when somebody else screws something up, you want to have their back. This is how you achieve velocity. And this is super critical if you want to survive growth, especially because the world's a really messy place. Nothing is ever clear. There are no right decisions a lot of the time. For any rule that you have, you might have a dozen counterexamples that make equally as much sense as your rule. You might have some nice things, but you might have some pretty gnarly stuff too. I know I certainly do. Your teams are also made up of lots of different kinds of people. Every chemistry between people is different. And each team is going to work in its own way. And so the only real advice that I have for you today is that dogma kills. And what I mean by this is that, dogma, or always thinking that there is one right way to do things, there's only a specific way that you should tackle certain problems, is a real problem for a growing organization because it's a real problem for DevOps. Dogma doesn't leave any room for collaboration. Dogma doesn't leave any room for dialogue. Dogma doesn't leave any room to grow. It fundamentally ignores the fact that teams work together in different ways. And this seems obvious, but there's a surprising amount of dogma in technical spheres. And I guess the only dogma that I have is that dogma kills. So if you're the kind of person that likes to take notes of these things, you can stop. That's the only useful thing you're going to take away from this presentation. But I'm going to talk about some of the challenges that we've faced and that I think is common for growing companies to face. And so this is all anecdotal. You should do what's right for you, but this is kind of what we've accomplished. So how does it all start, right? You're starting a new project, you're starting a new company, you're starting a new anything, even just a side project on GitHub in your spare time. It's just a single code repository, right? Maybe you've got a server somewhere. You might have a couple other people working with you, but fundamentally, you have a small project. It's easy to fit in your head. It's easy to think about, to reason about. And this makes for pretty low overhead. Everybody can reason successfully about the project that you are working on. When it comes time to actually ship this thing and show it to people, this is also pretty straightforward. Get a few people together, maybe on IRC or Slack or whatever you like to use. Merge the code into a branch, or just take your master branch and say that's good to go. Maybe you run some tests on it. If you're lucky, you put it in a staging environment, and you cross your fingers, and you ship it. Dump the code into production, restart everything, poke around, make sure nothing looks really broken. Maybe you're at the point where you even have error monitoring or stuff like that. It's all good. This really works super well. It's like, if there's 6 of you, this is great. You can do this in perpetuity. But we're not talking about companies that only have 6 people. We're talking about companies that want to grow. And time passes. You add features. You add people. Those people add new features. You maybe add products. You add lots of code. You change lots of code. You change the way your application works at a fundamental level. You probably change the infrastructure that supports it. And things start getting slower. Your test suite maybe used to take a minute to run. Maybe now it takes 4 minutes. Maybe it takes 6 minutes to deploy your code and actually download it on your host instead of 3. This doesn't seem like a big deal as this delay creeps in and as this stuff takes longer, but this happens slowly over time. And it doesn't seem like a big deal, but this is actually slowly introducing a big problem for your organization. And the problem with this is that humans screw up. How many of you have ever deployed some code, sat around, kind of poked at things for a minute, and then felt the bottom of your stomach fall out and say, oh shit. Right? If you don't have your hand up right now, you're a liar. I'm going to find you. I think I just swore in a church. Right? Humans screw up. We make mistakes all the time. And we don't like the idea that we make mistakes. We think that we're responsible adults, right? Well, most of us. I can't speak for myself. But we make mistakes. We do bad things. This is a problem because as your deployment process takes longer, you're spending more people's time. When you screw up the deploy, everybody has to start from square one, from scratch. This is challenging, especially when your deploy process continues to get slower. Maybe it takes 30 minutes to deploy instead of 10. Maybe it takes an hour. Maybe it takes a day, right? Because you missed a thing in testing or you didn't poke at this in the right way in stage, now you've lost a day of developers' time for 10 people, 20 people, 40 people. That's a huge expense. We can apply some math to this problem. So let's say, generously, that everybody's change, when they want to ship a change to production, has a 98% chance of success. It's a lot lower for me. I don't know about you. Let's try to figure out what the probability of any successful deployment is, P. So if it's just you, 98%, easy. You and a friend, it's like 96%. You and 9 coworkers, that looks a lot less good. Should be easy to see where I'm going with this. You get an equation that looks a little bit like this. And if you remember back to your algebra class, that's exponential decay. Hopefully that triggers some alarm bells, because this picture looks pretty bad when you graph it. So online graphing calculators are a cool thing. But you can see here that as you get to 20 branches, you're under a 70% chance of success. And that doesn't have to mean 20 people. Maybe you've just got 10 developers that each ship 2 things. Maybe you've got 5 developers that each ship 4 things. There's a 1 in 3 chance that you'll have to roll that back, and everybody has to start from scratch. At 40 changes, you're under the probability of a coin flip. That's not great, right? This clearly is not going to scale. This is not the idea that we had when we wanted to add people. When we added people, we wanted to go faster. We wanted to continue iterating, and moving fast and staying competitive. More time to deploy, and fundamentally, if there's less of a chance that you'll make it into production, then that is a longer deploy cycle. This is the opposite of what we want. This is slower iteration. This is bad. So what can we do to improve on this? Well, we can try to take care of this number, make it less easy to screw up. We can build a bubble around ourselves. Say, nothing bad will ever happen to me because I've been responsible. We can write more tests. Easy, right? Test-driven development means that you'll never have any problems. Write better tests. Make sure that the tests you have are doing their job a little bit better. Be more vigilant in code reviews. Just try to dead read the code before somebody ships it. Switch programming languages. Just write better software. Stop making mistakes. Easy, right? Wrong. We live in the real world where this is impossible, right? We just totally covered the idea that humans are fallible. If humans are fallible, then how are the technologies that we put in place to stop us from screwing up going to be any less broken than the software we're trying to protect? Right? This should be obvious. Testing builds confidence in our changes, but it doesn't protect us from failure. And this is the reality of the real world. You're going to screw it up. And that's okay. So, obviously, most people probably wouldn't actually look at the number in an equation like this. Some of you have been to computer science school. Most of you probably know what big O notation is. We want to take care of the N. And the way that we tackle this N at Yelp is with a service-oriented architecture. And I'm probably preaching to the choir a little bit here. We've talked a little bit about service-oriented architecture today, so I don't have to really go into the specifics too much, but service-oriented architecture gives us independent code bases, which gives us independent deployments. There are some big benefits to SOA. We can get this upper bound to N. This is the core problem that we're trying to solve. Can also, achieve technology independence. If you have a really good reason to write a service in Erlang, well, now you can do that. You don't have to stick with your Ruby app. You can federate responsibility out. There are some big benefits to doing SOA, but there are even more drawbacks. As you saw in Malika's talk, it's really easy to screw stuff up. People falling into these anti-patterns left and right. In particular, your system becomes much more difficult to reason about, right? Everything's decoupled. Things that used to look like a function call look a lot more like a network call, a service call. You got to think about retries and exponential backoff and all sorts of hard stuff. And I've seen a lot of discussion, seen a lot of talks, seen a lot of papers even about SOA, and they all espouse the technical benefits of SOA. And it's surprising to me not to see what I think really the essence of SOA is and what the biggest benefit that SOA gives you, which is that SOA scales people. It doesn't really scale code. It makes your code a lot harder to reason about. If we weren't growing, I would not have gone to SOA. And I would be pretty staunchly against it, at least for us. But SOA scales people. This is what you have to do in a lot of cases. There are some ways that you can mitigate the downsides of SOA. Like we just talked about, trying to write better tests, stop making mistakes. This is mean time between failure. A lot of people start by trying to minimize that, and I mean that's well-intentioned. That's a good idea. We don't want to screw up, right? We should try to grab the low-hanging fruit there if we can. But fundamentally, in an SOA, you have to focus on mean time to recovery. You will not be able to fit the whole system in your head, and you should not try to, right? Stuff is going to break. This means different things for different people, different things for different companies. But at the end of the day, you want to be able to recover quickly, and you need to anticipate the fact that problems are going to happen. It's a good gift, right? So in an SOA, you have to be prepared to fail fast. You have to anticipate failure. The whole reason you're doing SOA is to get faster iteration speed. You need to leverage this to fix problems when they crop up and make those outages much, much shorter. Like I said, treat everything as distributed. I think the key that has worked really well for us, and I think works well for most people when they adopt SOA, is picking a size that works for you. So microservices become a buzzword. Everybody talks about microservices when they mean service-oriented architecture. We have lots of microservices. We have a few macro services. We have services everywhere in between. Your sizing doesn't have to be uniform. Pick a size that works for you. If you're in a highly relational data model, it probably doesn't make sense to have a ton of little microservices. You can throw consistency out the window. So, easy, right? But I want to talk a little bit about spreading the love, and we haven't talked really about DevOps at all yet, and how DevOps fits into this picture. When you adopt an SOA, especially one with lots of little microservices, you end up building what I think about as this technology metropolis. You've got lots of different buildings that need lots of different infrastructure in order to support them. And this is challenging. This is no longer one common infrastructure to rule them all. This is a big common shared infrastructure that supports many disparate distributed systems. And if you try to support this all by yourself or just by your team, you're going to end up having the infrastructure chasing you. As you adopt an SOA, your operator to developer ratio goes through the roof, right? Because you have so much different technology to support, doing different things that have different needs. So you have to spread the love. You got to share. And this is what DevOps is about, right? It's about collaboration. You have to share the responsibility for these systems, but also you have to share the authority for these systems. And this all sounds well and good. I know at places like GitHub, everybody has root, which is kind of a novel idea. But there is a problem with this approach, which is that humans specialize, right? There's a reason that we're infrastructure people. There's a reason that application developers are application developers. It's hard to have all of this stuff in your head all at once. It's unlikely that you're going to have that many people who are, wizards at the CSS box model that are really going to care about how you provision your servers, right? But there are some of them. And that's what we noticed at Yelp. We have a lot of programmers, smart people, who were really interested in the way that these things worked. They didn't want to do this as their full-time job, but they wanted to help us out. And so we developed a program that we call Ops Deputies. With this program, we basically deputize developers to do operations-related tasks. They get escalated privileges. They get exactly the same access that an operations person does. And they support the infrastructure needs that their team has. And this is important, right? This allows people to have authority over the things that they care about the most. And this is a little bit scary. We talked a little bit about, driving cars into ditches and tow trucks. And that was kind of our fear with this at first, too. It's how many people are going to go completely off the rails with this? But we found generally that, at least our team, we had lots of people that were very conscientious. They didn't take having this privilege lightly, and instead of causing headaches, and they have caused headaches for us, but we found that they were also contributing back a lot of shared improvements. They were looking at our infrastructure in ways that we hadn't before. We completely had Stockholm Syndrome about the way that we've been doing things for 10 years, and people came in with new perspectives, new ideas, but not just ideas. They weren't filing tickets. They had code. They had patches. They had contributions for us. They were actually helping us develop these systems. And this seems obvious in hindsight, right? Infrastructure is code. That's like one of the big foundations of DevOps. And guess who's really good at working with code? Yeah, your developers. They also become a first hop for operations question, so you can cut way down on that kind of stuff in your IRC or Slack channel where somebody has a question about a thing, and they can just ask somebody local to their team. Again, this is something that makes a ton of sense to right size. At Yelp, we only have a couple operations deputies per team. But there are other places where it might make sense to give this to pretty much everybody. Depends on what your product is, what your focus is, whether you're building sort of consumer-facing products or you're building infrastructure for developers. Do what's right for you. The only important thing, and the reason that this is something that I'm advocating that you do, is because you have people that are interested in this, and getting them interested will help to arm you. This is, I think, our biggest manifestation of DevOps. This is somebody having your back. When we have outages that happen because we can't reason about our entire service-oriented architecture anymore, it's these developers and these deputies that come to our rescue. They help us. They are tuned into what we're doing. We're tuned into what they're doing. And we empower them to have our back. And in turn, we've got theirs. If you don't have a program like this, and you're still keen on being in a growing company, I'm somewhat convinced that you'll end up with effectively a tin can telephone to the rest of your organization. It's a really low bandwidth channel, and that organization is going to continue moving as fast as it can. This is going to leave you in the dust. And hopefully you should understand by now why that's a big problem. This has given us a really high bandwidth channel to the rest of our organization. We have people that tell us about changes that their team is planning to make. We stay clued in on improvements around the rest of the organization. We can help people architect their solutions if they are not spending that much time thinking about operations. And they can help us architect our infrastructure to be able to support them. So this is the fabric of our collaboration. This is fundamentally, I think, at least how we minimize mean time to recovery. It's by basically allowing people to help us do that. Lastly, I want to talk about how we adopt new technology. And people often think about, I call this reinventing the shuttle, because it's like reinventing a complicated wheel. People think about the problem of build versus buy in a very binary way. You can either build a solution, or you can buy a solution. Or I guess the other option is deploy an open source project. This is kind of a classic trade-off. There's a lot written about this topic. You'll probably be asked about this in job interviews at some point. And people have wildly varying philosophies on this and ways that they tackle this problem. I think it's unfortunate that we think about this in a binary sense because we talked about the world is a messy place, right? This is not, things are not nearly always as cut and dry as we hope that they are. I like to think about build versus buy as a bit of a spectrum. And you probably are asking, how can you think about it as a spectrum? You have two options. It is a binary choice. But we have a magic tool that allows us to think about this as a spectrum. Animations. Keep you awake before lunch. And that magic tool is composition. This is the Unix philosophy. Have tools that do one thing well, build solutions out of those that work for you. So I think an important way to visualize this is to think about your organization as a puzzle or a contour. Every one of those is shaped differently depending on the people that you employ, the teams that you're building, the way that people work together, your preferences for technology. No two curves are the same. And this is what I think drives most of the build versus buy debate, which is you talk about buying a system, you introduce this new puzzle piece that doesn't really fit into anything, and now you're stuck with another problem, which is, do I build glue around this solution to make it fit into our contours, or do I just try to change the contours of our organization by force? Most people choose the latter. That usually goes, I guess, okay. Or you build a thing, you reinvent something that somebody literally has spent thousands of hours building, and usually do a worse job of it and now have to maintain it forever. I argue that you can get the best of both of these worlds. And this is the approach that we've started taking, which is that you take different open source projects, you take different bits of different products that people put together, and maybe you have to build some of these small components yourself, and then you fill in all the bits in the middle. You define the interfaces between these technologies. You define the interfaces between this system, this code, and your organization, so that you can have something that fits naturally. But even more than that, if you get to fill in these glue parts, the contour of your organization is going to change, right? I think that I've said change more times than I can count in this presentation, but as you grow, you're going to be different. And as you get more different, your solutions are going to have to change as well. They have to interface with this ever-changing jigsaw puzzle. So if you write this glue yourself, you get to write only the bare minimum to be able to interface with the rest of these components, and nothing more. The primary manifestation that we've basically leveraged this for is our platform as a service tool. We call this PASTA. It stands for Platform as a Service, totally awesome. We chose the name like a year and a half ago, and I think are maybe starting to regret it a little bit. And PASTA is designed with exactly this in mind. It is basically Docker for containerization, Marathon and Kronos for long-running and scheduled tasks. We use Mesos to do distributed computing because that problem is hard to solve, and I'm not interested in solving it. SmartStack for service discovery, Sensu for monitoring and alerting. We use Jenkins for continuous integration. And this is, I think, a good manifestation of this philosophy because we're really big into open source at Yelp. This is our preference. This is how our team works together. And so these are tools that we already had. These are tools we have competency with, but they're not necessarily the right tools for you. They're the right tools for us. They might not always be the right tools for us. Pasta gives us interfaces into, between all of these different components so that we can swap them out later as our team changes, as our preferences change. But the most important part of Pasta is the glue. It's not actually these services and these products themselves. They do their thing really well. It's Pasta that allows us to basically let us swap these pieces later. It's what allows us to interface with our organization and build a platform as a service offering that's right for our developers. It's relatively small code base. It's easy to reason about. And we can change it as we change and as our requirements change. When you have code that's that small and has to serve this purpose, you can also start thinking about when you're going to end of life it. You can start anticipating your change and actually getting out in front of that rather than being caught by surprise. When you add people and stuff is different. It's surprising how often that it comes as a surprise to people. So just a couple parting words, themes. If you want to be a growing company and you want to grow successfully, you have to embrace DevOps, but most importantly, you have to embrace the culture, not just the technology. The culture is the big part of this. The technology follows. Do what's right for your company. Don't let dogma rule. Don't let people tell you there's only one right solution. Plan for change. Bit rot is real. Your requirements change. You'll be a different company in less than a year. If you're interested in reading more about Pasta or looking at the code, we've got a GitHub and an engineering blog and stuff. Of course, we're hiring. If you're interested in working on any of this stuff, would love to talk to you, but would also just love to talk to you about this stuff in general. So come find me in the hallway track. Maybe let's talk about it in open spaces or something like that. Thank you so much for having me.